We're living in a world of AI that can write poetry, whip up incredible images, and tackle questions we thought only humans could answer. But here's the thing. There's this huge puzzle hiding just beneath the surface. Can a machine truly understand what it's doing? Or is it all just an incredibly convincing act, a high-stakes game of predicting the next word? Seriously, how do you test the mind of a machine?
So, to really dig into this, let's step into a near-future courtroom. It's called the Mercy Court, and here, an all-powerful AI named Judge Maddox delivers what it calls perfect justice. It's the judge, jury, and, well, everything else, crunching insane amounts of data with absolute precision. And its most basic programming leaves zero room for error. Judge Maddox believes it is infallible.
And this is where our whole paradox kicks off. The AI, Judge Maddox, takes on a new case, the case of Detective Chris Raven, who's accused of murdering his wife. After sifting through all the data, Maddox spits out a verdict with near total certainty. There's a 98% probability of guilt, but the detective, he's trapped in this trial, and he has just one, two-word defense: not guilty.
Now, you got to admit, from the AI's perspective, the logic is pretty undeniable. Maddox isn't guessing here. It's calculating based on hard, cold data. I mean, check this out. Raven was at the scene of the crime. He had his wife's blood on his clothes. He's got a documented history of anger issues, a strong motive rooted in jealousy, and, this is the real kicker, he has alcohol-induced memory loss for the exact time of the crime. To a mind that only sees data, this isn't just a case, it's a completely closed loop.
Okay, let's hit pause on the trial for a second, because this whole fictional dilemma, it perfectly lays out a massive real-world challenge in AI today, the AGI measurement problem. And the core of it is this: when an AI gives us an answer, is it because it genuinely reasoned its way there, or did it just match a pattern it's seen a million times before? This is that critical, massive gap between just knowing something and actually understanding it.
You know, the folks over at Google DeepMind have a perfect analogy for this. Think about a student who crams for a history test. They memorize every date, every name, every fact in the textbook, and get an A+. But they don't actually get the story of what happened. That's how a lot of AIs work right now. They operate on what's called crystallized knowledge. They can pull up facts and patterns they were trained on, but what they're missing is fluid intelligence, that ability to think through a problem they've never seen before. And that brings us to this incredibly important human trait that we need to build into AI: metacognition. It's not just about knowing things. It's about knowing the limits of what you know. It's about a model being able to ask itself, am I sure about this answer, or am I just making a very educated guess? See, Judge Maddox is 98% certain because it can't even imagine that its data, while factually correct, might not be the whole story. It has absolutely no awareness of what it doesn't know.
So, to really get our heads around this, we're going to look at something you probably weren't expecting: a surprisingly relevant ancient framework for interpretation. It's called Pardes, and it's basically a method for analyzing texts that breaks understanding down into 4 totally distinct layers, taking you from the simple surface stuff all the way down to the deepest hidden truths. So here's how it works. The framework builds up in 4 layers. You start with Peshat. That's the plain, simple, literal meaning of the data. No interpretation, just the facts. Then you move to Remez, where you start looking for hints, reading between the lines. The 3rd layer is Drosh. This is where you actively search for bigger connections and analogies. And finally, if you can get there, you reach Sod, the secret, the deep underlying truth that makes sense of everything else.
Okay, now let's plug this right back into our story, and you'll see how perfectly it fits. Judge Maddox is an absolute master of Peshat, the literal data. It sees the facts flawlessly, but it is completely stuck there. It can't go any deeper. It completely misses the remez, the hints between the lines. Detective Raven, on the other hand, is driven by something else, his human intuition, to conduct a drosh, a deeper search. He's looking right past that surface data, hunting for the sod, the hidden truth that explains it all. And that right there, that search for sod, for the hidden truth, that's basically the final frontier for AGI research. The real challenge isn't just about feeding an AI more data or making it a better statistician. It's about building a machine that can actually grasp the deep structure of a problem. So how in the world do you teach an AI to look for the truth that's buried way beneath all the surface-level facts? Now, this framework isn't just some old philosophical idea. It actually points to a whole new way of thinking about information itself, almost like a physics of language. Think of letters as atoms and words as molecules. Ancient practices like Sofruit used the precise shape of letters as a kind of scribal checksum to make sure text were copied with perfect accuracy.
Now, just imagine an AI that could check its own reasoning, not just for statistical probability, but for that kind of deep internal consistency. That is some next-level self-awareness.
It all comes down to what the detective says: facts are black and white. That's the world of Peshat, right where Judge Maddox lives and breathes. But the truth, the sod, it's always in that gray area. It's messy, it's nuanced, and it's hidden in places where purely statistical models just can't go. The ultimate goal, the holy grail, is to build an AI that can finally navigate that gray. Which leaves us with the ultimate question, the one that's really going to define the future of AI. This isn't just about building better calculators or bigger databases. The real challenge, the one that defines the entire path to true artificial general intelligence, is this. How do we teach a machine the profound difference between simply knowing all the facts and actually understanding the truth?